Okay, welcome to antibody and immunity questions. First question, easy. Which cells produce antibodies? Plasma cells. Erythrocytes, red blood cells, macrophages are phagocytes, thrombocytes are platelets involved with blood clotting. Remember things like prothrombin, thrombin, fibrinogen, fibrin. That's all AS stuff that you certainly need to assume will be in A2 because of the nature of the synoptic. So you've got a situation here, new context, absolutely fine to deal with, to do with vaccines. So you've got to make sure you've got your vaccine knowledge. You've got these pigs, which if they get this condition called post-weaning multisystematic syndrome, PWMS, they have to be culled. So that's not a good thing for the pig farmer. So they've created this vaccine and they're thinking, let's give it to the mothers and let's just see what impact it has. So two groups, you've got group A and B. So group A, mama pigs, they're given the vaccine. Group B, no vaccine. So lovely control experimental group. How many times they get given it? In the information there, which I've underlined at various points just to highlight what you should do, with a highlight even better. So day 0 they get given the vaccine, day 20 they get given the vaccine, so I would even sort of mark on there. That's quite interesting, so knowing that that's group B there and group A. A final vaccine was given on day 140, boom, boom, and approximately 20 days before they give birth. Okay, final vaccine was given on, yeah, okay, so that's, I was just looking at that, so it sort of seems like they give birth then. Interesting, just imagining like 3 phases of a vaccine. Remember when I showed you the NHS rollout of vaccines, there were kind of considerable, like 3 months they're the same vaccine at 6 months. So this is common, and it's a sense of like, look, you're going to have even more of a secondary immune response if you have that. So it's a really good way of getting proper immunity if you have dosages of vaccines rather than just one. So describe how the vaccine gives active immunity. Okay, so obviously you need to know your terms. So you've got the artificial and the natural, artificial, natural immunity, so types of immunity, and then you've got active and passive, so just geeking up on that. Remember, like when you get ill, that's essentially natural active immunity. When you get given antibodies through the placenta or through milk, it's natural passive immunity. And then when it comes to artificial, so i.e. the doctor doing something, you've got artificial active immunity, that's been given a vaccine, and artificial passive, that is being given a booster antibody. A bit like if you get bitten by a rabies dog or rabid dog, you might have had the rabies vaccine, but then you might still be given a booster, which is a load of antibodies. Certainly the Ebola patients at the moment, they're being given Ebola antibodies, so artificial passive immunity. So describe how the vaccine gives active immunity. So there is the virus, I've done little glycoproteins there, and the vaccine, look, you can see I've changed the shape slightly, but same glycoproteins. It's a sense that it's a harmless or attenuated virus with the same antigens or glycoproteins. This is the vaccine. How good is that, Mark? Just easy as that. So then, that sense of what does this vaccine do? It activates T helper and B cells. Now, instead of going into all the details, that's in the mark scheme, you just say that in one line. So I've seen, look, you see I've got macrophage there, just like we did with that past paper question before. But this time, I've added in the idea that the B cells, after being B effector cells, some of them become B memory cells, which are long-lived. Some of the T helper cells become T memory cells. So after the activation, they then become T or B memory. These are the guys, especially, you know, they work together. If you get infected with a real virus, so imagine 2 years later or something, you know, after you've had this vaccine, you produce antibodies so fast and at higher concentration, so much that you are fine, you don't get ill. Apart from having no vaccine suggests how Group B should be treated, so it's a real how science works. Lovely Group B. All you want is the same conditions. And perhaps even that idea of give it a placebo vaccine. Okay, more important obviously with humans. But the same conditions such as food and temperature of the environment. Just technical term there, Group B is the control. And this is going to make sure it's a very much a fair test. The only thing that's changed is the vaccine, and that means it's valid. So compare the changes in concentrations of the antibodies. Now, this is something that I was worried that I've been too generous with the marks, because it's quite tricky to mark. But I want you to just be retrained with the view that you take one statement is a comparative statement, includes both A and B. You don't say all the things about A, then all the things about B. Every statement should refer to both. Okay, so higher antibodies in Group A than B. Always higher, you can see that. Group A uses so what have I written? Group A rises in first 30 days, Group B in first 20 days. Okay, so you can see that Group A is going up for 30 days, Group B only goes up to 20. Nice little comparison. Group A rise is faster for Group A. So even though you haven't referred to B, you've said that at the end, which really helps with the comparison point that you're making. Group B levels off before Group A, but Group A falls. Okay, so Group B levels and Group A falls slightly. There's a comparison point. After day 140, Group A increases, Group B decreases. So that's quite interesting. Group A increases and Group B decreases. Now you've got this one, credit comparative manipulated figures. At day 30, nearly 4 times as much for A. You know, you can imagine I've got to actually say that to get the mark. So at day 30, nearly 4 times as much. So I'm manipulating it, but that's actually kind of an interesting thing to say. You could do the difference, but that actually 4 times as much is really good as a point. So here we go. Here's all the piglet data now. So these lovely mothers who've been vaccinated and now have piglets. And so you've got Group A piglets and Group B piglets. And you're looking at the age of the piglets there. Ooh, 40 days. They're going to get quite big by that. So Group A, their mother had the vaccine. So when they are born, they've got naturally higher than Group B. Okay, we saw Group B mother did have some antibodies, so that makes sense. So 3.9 is a comparison to 0.7. That's going to hit that little baby, that piglet's going to have passive immunity. If that nasty virus called PWMS gets inside this piglet, it's got the antibodies, so it probably won't get ill. It's naturally protected. Okay. Piglet B, however, doesn't have such high antibodies, so perhaps just during this phase, it's actually not protected. Oh look, it's getting ill. Look, the fact that suddenly the antibodies are going up, that is related to its own immune system doing the primary immune response. Okay, so now I've just sort of commenting on the fact that look, the passive immunity comes via the milk. You get the antibodies, you can see the suckling going on there. And then Group A, the antibodies fall. And this is interesting because we say it's excreted, and that means it's removed via the kidney and passes out as urine. I think I said that the liver breaks down most of the antibodies, but in the mark scheme here, the excretion being the major contributor. B, here we go, gets infected, primary immune response. That sense of, can you remember the primary immune response? It goes up, and that is just making an explanation for that. Nice and easy questions, I think you guys got that. T helper cells, the ones that are invaded by the HIV, reverse transcriptase, RNA to DNA. Antibodies. Now, 2 characteristics, I think most of you did quite well with this, but made of 4 polypeptides. It's got a hinge region, so it's got 3-dimensional structure. That's quite AS synoptic. This is very much a sort of for 2 marks, to say variable region, which is the antigen binding site, and then the constant region is that bit there. That's the bit that the macrophages have the receptor for. Use the information suggests how this may enable scientists to develop means of producing active immunity. So basically this is exactly the same as that other question. Okay, so it's just sort of worded slightly different, which I wonder if some of you got. Can you see that picture there, that with the B memory and T memory? Very similar to that one I drew over there. So the same points. However, instead of it being an attenuated version of the virus, they're saying that they can synthetically produce just the glycoprotein, and that is actually fine for a vaccine. You can imagine you've got that glycoprotein you made, you can put it inside a little injection needle, and then you're going to have that activation of the B and T helper cells and the production of the memory and T memory. Okay, and I've just drawn that there to remind us. Remember that, so that could be like a vaccine going in, the primary immune response. You're not getting ill because it's an attenuated or it's just the glycoprotein. But if you do get the virus in the future in your body, you don't get ill because the secondary immune response produces antibodies so quick and so fast. HIV, some good figures there, so interesting, people receiving treatment. You know, it's basically suggests why data about HIV infections are often estimates, no symptoms so often, or they're common with other diseases. There's latency, so you've got the infection of the T helper cells, but they might stay in there without reproducing lots for a bit, i.e. like the gene not switched on somehow. So you need blood tests for it. Only some people want to take tests because the stigma attached to it. Anyway, there you go. Hope that was helpful.